Anshul, good afternoon. Right? One. Can you hear me?
Yes, sir.
Very good. Good afternoon. And who is here? Srinidhi.
Yes, sir. I'm on my video.
Ah, yes, very good. And Sanmitra, good afternoon. Can you hear me? All of you? Anshul?
Fine.
Yes, sir.
Yeah, Srinidhi, yes. Okay. Here we are having, what's your name? Priyanshi is here. Then Johan. Dia. Okay. Dia is also here. Huh? Rahi. Okay. Sanika. Very good. Rohan. Which school you from, Rohan?
Ramshed Thakur Public.
Ram?
Ramshed Thakur Public.
Panvel. Hargar. Okay. Good. Malva. Ramshed Thakur. Okay. Ramshed. Wow. Children, which topic you have started? Ivan, you are from which school?
Billabong and Malad.
Very good. Acha. Srinidhi.
Ryan International School, Sanpada.
Acha. Very good. Anshul.
Sir, I am from Indore, so I study in Shishukun.
Okay. Nothing to do. Sanmitra.
GAV.
The which topic you have started? Any topic you have started in the school? Huh? Matter in our surrounding. So children, first chapter is there. We'll go for matter in our surrounding. Okay. Let us discuss about. Can you see the screen? Yes. Okay. Now, have you got the notebook? I'll tell you when to write. Just first listen to what I'm explaining, then we'll start. Okay? All right? Today, first day for you all, this lecture. Just close your eyes, do 1 minute prayer, whatever prayer you do at home, so that you know this particular year you perform, your performance will be 100%. Isn't it? 100% marks everybody wants. Plus, just to go smoothly, take the blessings of your parents, of course, supernatural forces. Okay, thank you. Okay, so whenever you actually want go for your studies, you have to see to it that you take the blessings. Now, what is important over here? What is matter? Okay, so let us. Yes, don't worry, no. I'll just matter is something which is actually what has mass. Okay, and occupies space. Like this particular thing, marker is a matter. Why? Because it is having mass. Mass means weight. We consider mass as weight over here. Okay, and then what it occupies? Space. That means what is the other word for space? Volume. So anything which has mass and volume will be called as matter. So matter in our surrounding is whatever we actually come across here which has mass and occupies space will be called as matter. We ourselves are what? Matter. Right? Why? Because we occupy space and have mass. Isn't it? Okay. So the water which you drink, Srinidhi, not to write now. I'll give you some time. Don't worry. Okay. I'll give first. Second point is what, children? We know very well that matter, okay, can exist in different states. Okay. Now this particular marker is what? Solid. So we know very well there are three states, for example, three states of matter. That means matter exists in what? We can say, for example, of course, there are several states of matter. But in your syllabus, you are having three states. I'll tell you the remaining four also. But for the time being, okay, matter exists in the form of what? Solid. Now, how do you account for a solid? How do you say it is a solid? Now, anything which actually what? For example, you have some ice cubes. Okay. In a particular, let us say, vessel, the particles in the ice are closely packed. Yes or no? If these are the particles. Before we understand this, you know very well every matter is actually what? Made up of large number of what? Particles. Every matter is made up of particles. Account for it. Suppose you take one, for example, piece of sugar. Sugar which we eat, isn't it? Srinidhi, listen to it carefully. Okay? And I'm sure, listen. So what I do, I break this. I apply some force and I break this, okay, with the help of some, let us say, material and start hammering it. What actually happens to this big particle? It becomes smaller, yes or no? I further break it down. It becomes still smaller, yes or no? I go on breaking it. Okay? And I will find that it will become very, very, very small. Can you see on the board, children? All of you over there, can you see? Yes or no?
Yes.
Yes, sir.
What is important over here? Now, this particular particle cannot be broken down further. These will be called as what? Atoms or molecules. Or simply they will be called as what? Particles. Simply at this moment. So every matter is made up of what? Large number of particles, and these particles actually what? When they come closer, they may not show, for example, some kind of attraction, but every particle is having what? Attraction with the other. Clear? That means they can attract each other as well as repel each other. Clear? Well, that means what is important over here, that these particles are actually what? Having an attractive as well as repulsive force. How do you account for it? You take some bits of papers, okay, and then finally what you can do, take this plastic ruler and rub with your hair or on your hair, and finally what? Hit that particular ruler on those small pieces of paper. What is happen? It attracts. Or you run this particular hand on this after rubbing with some object, you'll find that the hair which is there on the arm gets raised. Yes or no? Sometimes it happens. And when it's brought very close, okay, that means what is happening? There's an attraction between two different particles, or maybe the particles in the same substance. Clear? So anyway, at this moment, remember one thing, that they are made up of large number of tiny particles. Now, if these are the particles, then definitely these particles are strongly attracted with each other. Yes or no? Okay. Why? How do you say it's attracted? Because they are closely placed. Right now? Now, if they are closely placed, that means there is some kind of attraction between what? These particles. And due to this attraction, okay, why there is an attraction? Because first of all, they are closely placed over here. Here. And at the same time, due to this, they will occupy what? They will have a definite shape. Yes or no, children? Definite shape. And also they will have what? Definite volume. Yes? Okay. So ice cubes, if you see, for example, how the ice cube looks like this, the children. Yes or no, more or less. That means they have a definite shape and definite volume. And what about the attraction between these particles? The attraction between this particle, that means this particular particle is attracting this particular particle, this particle is attracting this. So all of them are attracting each other. Yes or no?
Yes.
And since their attraction is actually what? Why it is high? Because the interparticle space is least. How do you account that is least? I want to compress this. I want to compress this. Am I able to compress? No. Why? Because there's no place inside. And since there's no place inside, because they're packed with each other, okay, or one another, and as a result, the interparticle space is least. And due to this interparticle space being least, the interparticle attraction is, yes, maximum. Attraction between the particles is maximum. Yes or no? At the same time, for example, what about the freedom of motion? Can they move these particles of the solid? Can they move? Suppose I'm placing this marker in this manner, children. Srinidhi, Vivan, Anshul, listen to it. Sanmitra, can I, am I finding that this particular marker is becoming longer? That means what it indicates, the particles are strongly attracted, they're pulled back. Okay, and this pulling back indicates, for example, the attraction is very high, and as a result, they are immobile. Yes or no? If I keep my finger in this manner, can you say, sir, your finger is becoming longer and longer? No. Why? Because the particles over here are strongly attracted with the particles, second last particle, third last particle. Strong attraction. Okay? So they're immobile. They cannot move. The freedom of motion is minimum. What I do, I take these ice cubes and I heat it. Heat at a given temperature of, for example, let us say, okay, above 0 degrees Celsius, heat unit, I just keep it out of the refrigerator and try to place it slightly above 0 degrees Celsius. What will happen? These particles which are actually closer, they will move away. Yes or no, children? That is what they will do. They will take that heat and they will use that heat to separate one another. Yes or no? And finally, what will happen? They will become what? For example, they will lose that particular, that is, they will not have a particular definite shape. Why? You will say, sir, how? If I put this particular, for example, liquid in this glass, don't you think the shape will be different? Let me write in this from this direction. Okay. So what will happen there to the shape? Look at this. The shape is in this manner. Earlier shape was in this manner. Yes or no? Ice cubes. Now the shape has changed. That means they don't have a definite shape. And this kind of state of matter is called as what? Liquid. And when the solid changes into liquid at a given temperature, then that particular process is called as what? Melting process. And that point is called as what? At which the solid changes to liquid at a given temperature. That is 0 degrees Celsius is the melting point of ice. Okay? That's definite. That means the shape is not definite. Yes or no, children? No definite shape. But definitely they are having what? A definite volume. What about the interparticle space is actually what? More. What about this attraction between the particles is what? Maximum. Here it is. Attraction is lesser. Yes or no? And what about this immobility? That means they become what? Mobile. That means the freedom of motion is what? Slightly more. Like for example, I take a water in the glass and just tilt that glass. What will happen? Water will move. Yes or no? There's a mobility. Yes or no? So what I do, I further heat it, children. When I further heat it, and let us say make it to 100 degrees Celsius. The moment I make it 100 degrees Celsius, in the same vessel, whatever liquid particles are there, attraction is there. Okay, attraction between them is there. That is broken down because when I heat it, the attraction is broken down. The attraction break will happen. And therefore, what will happen? The particles will be free to move around. Yes or no, children? Okay. And at this particular temperature of 100 degrees Celsius, the liquid changes into what? For example, children, gas. There's a third state of that. Because that heat is going inside and changing that particular liquid to gas, and therefore here you will not find any definite shape. No definite shape, no definite volume. At the same time, the interparticle space is least. Here, interparticle space is maximum. Yes or no? Attraction between the particles is what? Here maximum, this is lesser, this is, and here this is immobile and this is mobile, this is highly mobile. And since they are moving, okay, what kind of energy they are possessing? They are possessing, for example, kinetic energy. Children, what is that? This energy which is related to the movement is representing what? Kinetic energy. So the kinetic energy is, that is anything which is moving, okay, is having highest kinetic. So gases are having higher kinetic energy, okay, maximum. The kinetic energy over here is less, and this is kinetic energy is least. Children, what is the opposite of kinetic energy? You've done in your, for example, 8th standard. Potential energy. Water stored in a dam. So anything stored means not a mobile. That means it is having potential energy. How that particular water in the dam, when actually what? When I just open the dam, what will happen? Starts moving. The water starts moving. Okay. Trinity, water stored in the dam, when we actually open the dam, what will happen? It starts moving down. Na? So what happens? When it is stored in the dam, it is nothing but what? Potential energy. When it is moving, it is changed into kinetic energy. Okay. So anything, for example, particle moving will have kinetic energy. Any particle just stationary, like book is not this movement, is placed over here, it is having potential energy. But fan which is moving is having what energy? Children? Kinetic. So there are two main energies over here. Clear? So if the kinetic energy is least, what will happen to the potential energy? It will be, yes. So solid के पास potential energy maximum है चीज़. तो दोनों मिला के क्या होगा? Total energy is constant. यानी इसका अगर 100 है तो इसका 0 हो जाएगा. So 100 plus 0. Kinetic energy is 50. Potential energy is also 50. What is it, children? Potential energy, kinetic energy is less. Potential energy is more. This maximum, na? This maximum. So, with respect to this particular potential energy of the solid, potential energy is slightly less. Yes or no? Okay. So, what is happening? Both are less. Means moderate, we can say. 50-50. How much is it? 100. Here kinetic energy is maximum. This is 100. Potential energy is minimum. Yes or no? ये maximum ये minimum है. यहाँ पे क्या है? ये minimum ये maximum. और यहाँ पे क्या है? Both are moderate. Okay, so total energy of any matter, provided masses are same. जब आप सब mass सब same रखेंगे, तो आपका total energy constant. Okay, children. Vivan, what is the first point? Solids have definite shape and definite volume. Interparticle space is least. Attraction between the particle is Anshul maximum. Yes or no? Are the solids mobile? Are they having the freedom of motion maximum or minimum?
No, minimum.
Minimum. Very good. Kinetic energy is minimum or maximum?
Minimum.
Minimum.
Potential energy is
Maximum.
okay. Here liquids that they don't have a definite shape but definite
Volume.
unity volume. What about interparticle space? Is it more or less?
More.
More. What about this attraction between the particles? Is lesser than solid or actually more than solid? Lesser than
Yes,
solid.
yes.
Are they mobile? Yes. Are they? Can they move? Yes.
Yes.
Okay. You take shampoo and you find, for example, it starts moving. Okay, when you just open the bottle. Likewise, honey starts moving. What is that? Liquid, mobile. Kinetic energy is moderate. Potential energy is also moderate. Okay, I'll write over here. नहीं तो क्या होगा? Less लगेगा आपको. Moderate. Okay, children. Here, this is also moderate. Okay. And what about gases? Now, let me tell you before that. Srinidhi, listen to it carefully. Sanmitra, liquid converting into gas at a given temperature means what? This is known as what? This particular process is called as boiling process. And that point is called as what?
Boiling point.
Yes, very good. Excellent. Hats off to you all. Okay. What about the interparticle space? is max. What about attraction between the particles? There is maximum. This is lesser. This is least. And what about this? Here, solids are immobile. Particles are immobile. Liquids are what? Particles are mobile. That means they can move. Here, they're highly mobile. That's why you're sitting and inhaling oxygen, isn't it? Am I right or not? Why? Because oxygen is coming into your nose. There's no need for B to move from one place to another. Right? And what about kinetic energy maximum? This is okay. Now, children, let me tell you one more thing. Srinidhi, listen to it carefully. If I cool it, now you have to give the answer. If I cool a gas and make it actually what? Lesser than 100 or more or less to 0 degrees Celsius, slightly zero, above zero, what will happen? This particular gas will change into what? Huh? It will change into
Liquid.
at that point at which this particular gas changes into liquid slightly above zero, slightly above zero is known as what, children? It's called as yes, condensation. And that particular point is called as what? That process is called condensation process. Okay, particles will come closer. Why? Because you're removing heat, and when you're removing heat, what happens? Particles come closer and attract each other. Okay, like suppose for example somebody is very much angry, what do? You run away from that particular person. But when he cools down, okay, what you do? Again you come back. Like teacher is angry, immediately students run away. Isn't it Srinidhi? Unsure, right? I mean, run away means in the sense you just move away from that particular, for example, that teacher who is angry. So, but when the teacher cools down, what happens? Children again they come over with condensation. They come closer. Clear? At the condensation point, and this is nothing but almost 0 degrees Celsius. Now I further cool it down below 0. What will happen?
Freezing point.
Yes, cool it down. And what is that point called as? Yes. That means some people you say, sir, he's a super cool person. The teacher is super cool. Yes or no? And some are actually what? Like some people are said, sir, the teacher is always boiling. Am I right or not? What is the idea behind it? That is the nature, of course, at a given temperature and at a given pressure. Remember one thing. So this is the kind of nature. You cannot say, sir, this is good or this is bad. You're just trying to understand, for example, 4 processes. One is melting point. Second is boiling point. And these examples are related to this. Just keep it to this only. Okay. So the melting point. So what is melting point? At a given temperature and pressure, when a solid changes into liquid, it's called as what? The melting point of the solid. Well, it is nothing but, for example, temperature at which a liquid changes into a gas here under atmospheric pressure. That is called as boiling point. You're changing, for example, a gas into liquid at a given temperature, and of course at atmospheric pressure, it is called as what? The condensation point or condensation process. And if you're converting a liquid into solid at a given temperature, here under atmospheric pressure, it is called as what? Freezing point. Now Srinidhi start writing. Children, here everything you have to write. If any doubt is there, children, we can ask. Ivan, have you got the notebook over there?
Yes, sir.
Very good. Sanmitra, are you having it?
Yes, sir.
Yes. Oh, abhi aayega. Thoda sa. Abhi, I just those words I am not putting now. Then one more important thing this child has given. What's the name? Rahi. Rahi has given this information that gases can be compressed. Is it true or false? Can you compress a gas? Yes, sir. Yes. Right? How we, for example, take that, fill that particular air in the car tire. What is that? Compression, na? Children. But can you compress a solid? So solid cannot be compressed. Liquids cannot be compressed to that great extent, but gases can be compressed. Can we expand a solid? Yes. Okay, but expansion means what? Of course, when we heat it, then only it can expand. Clear? And here liquid also can be expanded, but to very minimum extent. That means here expansion can take place to minimum extent. Here also expansion can take place, but gases can expand to a very high, for example, value. Why? You just heat it, they start moving out of the room. Yes or no? So that expansion is appreciable. These expansions are negligible. Okay, solids and liquids cannot be compressed and expanded infinitely, but gases can be compressed infinitely as well as expanded infinitely. Infinitely, बहुत ज़्यादा कर सकते हो, infinite. Compress का मतलब है एकदम नजदीक. Like all this, so many molecules in this particular room of air can be compressed in a small vessel, in a tire of a car or a truck. इतना बड़ा volume of air can be compressed. Children, what we have done in our, for example, CNG, what is that? Compressed natural gas. So compressed word is there for the gas. What about our LPG, children? Liquefied petroleum gas. That means we can convert gas into liquid under pressure. I'll just tell you that particular part also. Which are the two main factors which decides the states of matter? पहले लिख लीजिए. Why gases, solids cannot be expanded, children? Because attraction is high. They don't want to expand at a very, very small difference in the temperature.
So the last exam we expanded, right?
But infinitely we cannot expand. I mean, we have to supply a very high amount of energy. But for gases, little heat, they expand. They move out of the room, isn't it? Okay. They can be expanded, but some definite value. But they can be indefinite. What is the heat supply? Your gas will go out. Or pressure release, immediately gas will come out of that cylinder. Yes or no? Sometimes you off the gas, on the gas burner, but without lighting, what happens? Fine coming in from the orifices of that person, that burner, isn't it? Return. Children, moment you finish, just say done, sir. Those are over there online, then I'll come to know. Clear?
Yes.
Thumbs up. Virtual.
Done, sir.
Very good. Srinidhi. Srinidhi has completed. Good. Now, others are just doing on the words of completion. Anshul has completed.
Yes, sir.
Very good. Vivan,
So just 1 second.
no problem.
Done, sir.
Just Samitra has done.
Yeah, done, sir.
Good. Vivan has completed. Done. Good. Done. Here also, Rahi has finished. Then, Sanika has completed. One is, what's her name? Six. Priyanshi. So Priyanshi has completed. First day, it will take some time for me to maintain your names. And you, Sohan. Okay. And
Yeah.
yes. Finished, na? Good. Now, children, let us come to the next part, and that is what are the factors which actually work. For example, on which the states of matter depends. There are main two factors. Okay, that let us understand that, and then we'll proceed further by reading the content from the book. Or if you are having the volume, or you are having the book, okay, no problem. Now, one student will read out, but not now. Let us understand this. Here, you can write one more point as Rahi said. What is that? Gases can be compressed and expanded infinitely, isn't it? Whereas solids and liquids cannot be compressed here or expanded to a great extent. That means they can expand or contract, but to a definite extent only, or to a small extent. Why? Attraction is comparatively higher in the case of solids. Right? Okay. Now, what is important over here? The factors affecting. पहले ये देख लीजिए factors. Affecting the states of matter. Okay, children. There are two factors which affect the state of matter. One is temperature. Temperature is nothing but what? It measures the kinetic energy of a state of matter or of a substance, of a matter, you can write. Okay? Measures the kinetic energy. That means kinetic energy. Why? Because molecules, particles, they keep on moving, especially for gases. In the case of solids, little bit vibration will be there. Like this solid, you will not see from outside vibration, but inside the particle has a little bit movement, depending upon what is the temperature. Summer it will be slightly higher, winter it will be slightly lower, isn't it? Okay, so that measures the kinetic energy of the matter. So what is happening as the kinetic energy is raised? In the case of solid, the solid changes into liquid. Again, you raise the temperature, that is kinetic energy of the molecules increases, and what will happen at one particular point of time? The liquid converts into what? Gas. Okay, so kinetic energy, okay, temperature. So in other words, as you increase the temperature, children, increase the temperature, okay, will increase what? The kinetic energy, and it will increase what? Or it will change a solid to liquid and liquid to gas. That means when you heat, for example, a particular solid, okay, and that means you raise the temperature, kinetic energy is raised, immediately changes into liquid. Okay, and when you again further heat it, you'll find it changes into gas. That means the kinetic energy in the case of gas will be maximum. That's what I was trying to do. Okay, so that means as you increase the energy, you find for a molecule, the state of matter goes from a lower state to higher state. Right now? Okay. Did you follow this? Okay. Second factor on which, for example, it depends, and that is nothing but what? Pressure. Right? So what is pressure, children? When we are talking about atmospheric pressure, this is the earth, yes or no? And there are layers of air, yes or no? Or gases. Gases are exerting a pressure. Now, for example, the gases vertically, when they exert a pressure on this particular area, okay, this is the area on this particular earth surface, and the gases are exerting a pressure. That means they're exerting what? A force on a particular area. Since the force is actually exerted by the air particles, okay, there is a group of molecules of particles on the surface. It is called as what? Pressure, or it is called as what? A thrust kind of. Thrust means pressure. Pumping. Clear? Like some person is actually having a heart failure. What the doctor does? He pumps, for example, that particular the heart or maybe the chest, and finally what tries to revive some kind of, for example. So pressure has to be applied over there. That means pressure means he's applying a force on that area, and finally you find that sometimes a person may revive. It's a question of life. So what is important over here? Now it's like saying this. Let me show. Now if this is the area, a square unit. Okay, on this square unit, group of molecules are striking. Definitely the air molecules are coming on this area. Some fixed number of molecules are striking, banging, applying a force. So this force exerted on this area is nothing but it's called as a pressure. Yes or no? Okay. So this particular pressure, since it is coming from the air or from the atmosphere, this pressure is called as, children, atmospheric pressure. Okay, atmospheric pressure. Now this pressure will decide whether that particular gas will change into liquid or not. For example, when we apply a pressure, what actually happens? That particular gas changes into liquid, yes or no? When I apply further pressure, that liquid may change into what? Solid. So higher state of matter changes into lower state. That is under pressure. Just like CNG, children, compressed natural gas. Or, okay, let us say for example LPG. What we do? We have liquefied petroleum gas. Yes or no? That means there we apply pressure. Now we come to the pressure is there. Moment you on the knob, what happens? Some sound comes. What happens? It is under high pressure. Knob locked, okay. So the moment you release the pressure, what will happen? It comes out, and of course through the pipe, and then from the gas stove we can see. So that means what happens when you release the pressure, that liquid changes into gas. When you increase the pressure on them, the gases come closer and become liquefied. Remember, so pressure is an important factor. Okay, likewise, you know very well, when we make some food in the pressure cooker, what happens, children? The temperature, the boiling point of that particular water is raised from 100 to 120. Right? How do you say that it's raised to 120? That means whenever we increase the pressure, the boiling particular liquid is raised. Okay? That means the same liquid is boiling at 120. So softening of food takes place faster because of pressure. वही चीज अगर आप अपना ओपन वेसल में करेंगे तो कितना टाइम लगता है? जो हाफ एन आवर में, like for example, cooking of food is taking place in the pressure cooker. Okay, it's taking 1 hour without pressure cooker. Why? Because the pressure is not applied. Right? Because vessel is open. Right? So that means when you apply a pressure, the boiling point is raised. But when you increase the pressure, children, what about the melting point? Melting point will decrease or increase. अगर आप प्रेशर अप्लाई करेंगे, सपोज फॉर एग्जांपल, ओके, कोई सॉलिड के ऊपर, तो उसका मेल्टिंग पॉइंट इंक्रीज होगा कि डिक्रीज? बॉइलिंग पॉइंट तो इंक्रीज हो रहा है फॉर अ लिक्विड, बट मेल्टिंग पॉइंट विल एक्चुअली डिक्रीज और इंक्रीज. वो जल्दी मेल्ट होगी, इट विल टेक हायर टेंपरेचर टू मेल्ट. Decrease, rightly said. And when you actually increase the temperature, okay, when you increase the pressure, boiling point is increased. When you increase the pressure, melting point will decrease. उसका उल्टा हो जाएगा. And अगर आपको एक solid को जल्दी melt करना है, apply the pressure. For example, you must have seen that how that person makes a gola. Okay, I mean, of course, that is a mechanical pressure. What he does with the help of machine, actually, what he crushes the rice piece, and then what he uses both his hand and then applies the pressure, mechanical pressure. And what happens? The rice particles, okay, they come together and remain for in the solid state for some time. Just an example, just to understand. So pressure and temperature are the two factors which can affect the states of matter. Write down. Okay. Now we'll start reading the content, but after you have completed. Okay, just one more point to remember. Okay, I'll just. Okay. Unit क्या है इसका? You know very well. What is the unit of temperature? Degrees Celsius. इसको कैसे लिखते हैं? Degrees or Kelvin. Of course, that conversion I will tell you afterwards. Okay. Like our unit of money is what, children? Srinidhi, Sanmitra, unit of money is what in India? This rupees. In America, it is dollars. So likewise, but both are actually what? Representing money. So likewise, degrees Celsius is one way to represent temperature or Kelvin. Likewise, atmosphere is one way, or Newton per meter square is the other way. Newton per, because force is expressed in Newton. Physics में आपने पढ़ा होगा Newton. And area का unit क्या है? Meter square, centimeter square, length into length. So either इसको अभी conversion I will tell you, but at this moment atmosphere or Newton per meter square. Okay, na? Now, the last point before we go for reading parts of it. What is that? Okay, children, let us come to this. The concept of हो गया, सबका हो गया. Everybody has written. Who's still writing? Vivan, are you writing still?
No, sir, done.
Very good. Sanmitra,
Yes, sir.
ठीक है. Here you have finished. Good. Finished. Children, before we actually go for reading part, going for some questions, एक और content कर लेते हैं, so that at this juncture we can actually revise the parts. Okay? Children, one important thing you must have seen. Shall we start? Huh? Rub this out. Okay, सबका? Okay. Now, children, let us come to force exerted. Already I have told you by number of particles. Okay. So now let us come to one more point. Here, now here I take a chalk. Three important things I take. One is a chalk, normal chalk. Okay. Second is normal liquid, like let us say water. Third, I take, for example, let us say, we can say container containing a gas. Okay, and this one more container I am placing. Okay, and this is, let us say hydrogen, and this is chlorine. Good. And here I am having hydrogen. Let us say I am just showing different colors. Okay. And here I have taken chalk and I put some amount of, let us say, I just dip this particular chalk in, let us say, for example, water. So ये chalk है, ठीक है? और उसको पानी में हम लोग डुबा देते हैं, ठीक है? This is water. I put some amount of fountain ink in this water, ठीक है? Like for example, this is water. Now what will happen? Let us see. The water which is actually just in which the chalk is submerged, what will happen? It will start passing into that particular chalk. Yes or no? Slowly and steadily. Here the ink will the moment I put some ink or maybe some kind of glue absorb, okay, they start moving into what? For example, slowly and steadily inside. Here I remove this particular lid to barrier the beach mein. And then I find, for example, this red color particles of hydrogen. Okay, like chlorine is a greenish yellow gas, hydrogen is colorless. So ऊपर वाला container colorless था और नीचे is actually what greenish yellow. After some time I find, for example, both the are having what? Greenish yellow gas, but little bit lighter. Yes or no? So what it tells me? It tells me that here there is an intermixing of two substances. Yes or no? That means here chlorine has moved up, okay, mixed up with hydrogen. Hydrogen has come down, and this particular process of intermixing of two substances. Same way here, the ink has gone inside and actually what has made the water colored. Likewise, this water which has entered into the chalk has made the chalk heavier or wet, we can say. But this intermixing of one substance into the other, okay, is known as what? Children, known as irrespective of the nature, irrespective of the gravitational force, irrespective of, for example, density, they start mixing. This intermixing is called as what? Okay, between what? Between two different substances. For example, if I just let us say, for example, burn an agarbatti over here, its smell is spread after some time over there also. Or suppose mother is preparing good food in the kitchen, so how will you come to? You are sitting in the drawing room. After a few minutes, find some good fragrance or good smell of that particular. For example, frying of samosas and other things are actually what? Moving into your nostrils. What is the reason for it? Diffusion process. Okay, or good food is actually, or maybe the food is being become or food is getting ready. Am I right or not? So you get a sign through this diffusion process. Okay, children. So what is diffusion? Diffusion is intermixing of what two or more substances, irrespective of the density, irrespective of the nature, irrespective of the gravitational force. ये देखो, हाइड्रोजन नीचे जा रहा है, क्लोरीन अगेंस्ट द ग्रेविटी जा रहा है, yes or no? ऊपर चला जा रहा है. So this is nothing but irrespective of the gravitational force, irrespective of the nature, which is heavier, which is lighter. देखो, heavier gas ऊपर जा रहा है, lighter gas जो ऊपर होना चाहिए नीचे आ रहा है. Yes or no? This is called as diffusion. That means another property of matter or another property of particles. They can clear? Okay. So now children, open your volume, all of you. Volume open कीजिए. कितना time बच हो गया? से ठीक है ना? हाँ देखिए. Now Rohan will read out. Children, page number. What is the page number, child? Page number 1. Okay. Rohan is reading the first sentence in the introduction. All of you are having the volume. Read out first sentence.
Okay. Introduction. Everything in this universe is made up of material which scientists have named matter. Everything is matter. As we look around, all the things occupy space and have mass. In other words, they have both mass and volume. The early Indian philosophers classified matter in the form of 5 basic elements. The Panch Tattva.
Panch Tattva. Children, that means Panch means what? 5. Tattva means materials or matter or elements. Where we are saying. Come on. Which are those?
Air, earth, fire, sky, and water.
Yes. We are made up of Panch Tattva. Air is there. Water is there. Space is there. Clear? Our skin is nothing but what? Our body is like earth.
Modern day scientists have evolved 2 types of classification of matter based on their physical properties and chemical nature.
Srinidhi, read out next part from there. Where you stop, Rohan?
I read the whole introduction.
Whole introduction he has read. Now you go for the next part of the introduction. What is that? Physical nature of matter.
Physical nature of matter. Matter is made up of particles. Particles of matter are small. These are millions of tiny particles in just one crystal of a substance which keep on dividing themselves into smaller and smaller particles.
Very good. बहुत ही अच्छा पढ़ा. Next part पढ़िए. Characteristics of particle. पढ़िए आगे पढ़िए. Read further.
Characteristics of particles of matter. Particles of matter have spaces between them. Particles of one type of matter get into the spaces between particles of the other. This shows that there is enough space between particles of matter. However, the original level of the liquid does not rise. Particles of matter are continuously moving. Particles of matter are continuously moving, that is, they possess what we call kinetic energy. As the temperature rises, particles move faster. So, with increasing temperature, the kinetic energy of the particles also increase.
Then, very good. Next one.
Particles have interparticle spaces. Particles of matter intermix on their own with each other. They do so by getting into the spaces between the particles. This intermixing of particles of 2 different types of matter on their own is called diffusion. On heating, diffusion becomes faster. Particles of matter attract each other. Particles of matter have force acting between them. This force keeps the particles together. The strength of this force of attraction varies from one kind of matter to another.
So where the forces are reached? In the case of gases, attraction सबसे ज़्यादा solid. Yes or no? Clear? Very good. Well read. Okay. Now children, उसके बाद आगे पढ़ना नहीं है. अभी फिलहाल, अभी let us go for questions. On the next page, you will find some questions related to that. Clear? Okay. What is that question number? Okay, next question दिया है. Activity के बाद देखिए. Questions. और next one. Either first question. Question है ना? Now children, which questions we can do in these, page number क्या है? चाहिए? 9. Children, 9 or 10? 9. Page number 9. All of you open page number 9. उसको देखिए, which questions we can do in this lecture for 1 or 2 minutes, जो भी time बचा है. I hardly only 1 minute is there. Which question? नहीं, page number 9. Page number 9. 9 है क्या? ये कौन सा पेज नंबर 10? चलो पेज नंबर 10 नेक्स्ट पेज है ना, वो तो एक्टिविटी हम लोग बाद में करेंगे. पेज नंबर 10 में देखिए, पहला क्वेश्चन क्या है? व्हाट इज द फर्स्ट क्वेश्चन?
Which of the following is matter?
Which is the, now this is very important. Which of the following is a matter? Now all of you try to find out which is matter and which is not. Children, opposite of matter will be what? Yes. What is the other word for antimatter? Antimatter means energy. Okay, which is massless and does not occupy space. Chalo, first let us quickly go for that answer. What are the examples given over there?
Chair, air.
Chair. Chair is a matter or not? Who would like to give the answer? Police. Chair is a matter. Very good. Put a tick mark over there. Second.
Air. Air is also a matter.
Air is also a matter. Anshul, third example क्या दिया है उधर?
Love.
Love is matter or not? Is it energy? Huh?
No.
Yes. No, it is anti-energy. ठीक है ना? Doesn't occupy space and has mass. I mean, we cannot say, for example, it is. Then next one, Vivan, बोलिए.
Smell isn't the matter.
Smell. Smell is matter or not?
No, it isn't.
No, sir.
It is not. Okay. Then next one, Sanmitra.
Heat.
हाँ, pardon? Heat. Matter है क्या?
No.
नहीं. There is no question of mass and energy. But the next one, elements. Elements matter है क्या? Yes. Then next one. उसके बाद कौन सा एग्जांपल दिया है? Heart. Thought is matter or what, children?
No.
No, sir.
No, antimatter. Thought क्या है? It doesn't take space as mass. Sir, what is the weight of your thought? कोई बोलेगा नहीं. ठीक है कि नहीं? Okay. So then cold. Cold क्या है?
No, sir. It's not a matter.
Cold is also kind of what?
No, sir, it's not a matter.
Pardon?
So it's not a matter.
Then very good. Srinidhi, next one. हो गया?
Sir,
Cold drink.
we can tell how much the
So
temperature.
it is a matter.
We can measure it.
Really temperature, but उसका temperature तो सबका measure कर सकते हैं because वही temperature जो room में वही temperature होगा ना. But normally when we don't have mass and energy, or sorry, space, it is out of that matter. Here, okay, children. Any other point is there? Okay, na? Cold drink. Cold drink is matter or not?
Yes, sir.
We can easily weigh that, and at the same time, it has got, for example, to occupy space. Any other?
Smell of perfume.
Smell of perfume. Okay, smell of perfume. Now, perfume is actually what used as a matter. उसका smell में particles होगा. It is matter. Just ordinary smell will not be a matter. समझ में आया कि नहीं? Smell means what? It is not actually what, for example, considered to be an antimatter. So anything which is related to feelings, okay, or related with thought process will be called as antimatter. You can smell, but smell from a particular matter, then it is definitely coming and saying that it's a matter. Okay, I think so. We'll stop over here. Homework will be only reading part of this topic till here. Next time we'll go for other parts.
Sir, from where to where?
That whatever I've given you, this next page. Page number. Yes, children. Page number 1, 2, and till here. Matter can change its state. इसके ऊपर. Yeah, ये title के ऊपर. ठीक है? Just go through, and then if any kind of doubt, next time you ask.
Sir,
बोलो
Can you type the homework in the chat box, sir? I'm not able to hear you properly.
chat box ना here. अच्छा नहीं, I will tell you again. See page number 1, page number 1, page number 2 and page number 3 का जो ऊपर part है ना, what is that? Before matter can change its state. Matter can change its state. Before that, whatever I, is there, read. Clear?